in the program over the last few years. We're one of just over 20 New Jersey high schools, and we've been assigned a number. We're West Morris Central is number 57, and all the clones that my students, these are the 8 that I did this summer, as we do our sequencing, and we submit this, and if it's novel, they'll send it in to get published. If it is a novel protein, and I hope that each and every student gets to find a novel protein and get published this year. One of the things that can happen per school, one protein we can send that out to the Midwest. There's a company, you see the picture on the right, where they actually, students, the protein that they discover, they can actually make a model and they can display it here at the school. So it was an intensive program, but it was amazingly and intellectually challenging for me, and where I'm going to get my most gratification is my students and their same experience. Thank you.
Hi, I'm Bruce Tadrick. I teach environmental science at Mendham, and I like going out into the world and doing environmental research because it gives me some good experiences that I can bring back into the classroom and try to get my students excited about environmental science. So, like Nicole, Ms. Pavlin, in 2009, I won an Earthwatch fellowship funded by the Geraldine R. Dodge Foundation to work on a research project called Climate Change in Caterpillars in Ecuador. And I spent 11 days at a remote research facility in the cloud forest of Ecuador. So I definitely got away from New Jersey. We got a 3-hour bus ride from Quito over the crest of the Andes. So what we did on that trip, we stayed at this lodge. It's called the Yaniaki Research Station at about 7,000 feet in the cloud forest. It rained every day. And it was built by a scientist about 10 years ago. There's absolutely nothing around there. It's very pristine, biodiverse cloud forest. And what we did, this is the view from my room. We were studying the relationship between parasitoid wasps and caterpillars. And most people don't know this, but the main predator of caterpillars are these wasps that lay their eggs inside the caterpillars, and then the wasp larvae eat the caterpillar from the inside out, kind of like the movie Aliens, and kill it. So it's kind of a strange relationship in nature, but it's very important because in most environments, caterpillars are the main organism that's out there eating trees and foliage. They keep they do a lot of damage to crops, and parasitoid wasps are one of the only things that keeps caterpillars in check. So what we did to run this experiment was we literally went out into the rainforest and beat the bushes. That's me beating the bushes there, trying to find caterpillars. And we would beat the bushes and then look at these sheets that we call that a beat sheet. We beat the bushes onto them, and then we'd find caterpillars. We would also go out into rivers and just search leaves by hand, collecting caterpillars all day. It's actually a very good program for volunteer researchers because you don't need a whole lot of experience or knowledge to go find caterpillars. So there were 11 other teachers with me on this trip. So we would find our caterpillars and then bring them into a laboratory and rear them. Every day we would check on the caterpillars to see if they had turned into a cocoon and become a butterfly and moth, or whether they got parasitized by wasps. And this is a caterpillar that was unfortunate enough to have a wasp lay its eggs inside it, and the larvae hatched, ate the caterpillar from the inside out, and then formed their pupae on the caterpillar, and eventually wasps will hatch out of this. So the whole point of this research, I was working under a professor from Tulane University who has been doing this research for 15 years all over the world, from Ecuador to Costa Rica, Arizona, Canada. He's raised over 500,000 caterpillars in the laboratory. And this is the results of his study, the only very sciencey slide I'm going to throw at you. But if you look, on the x-axis is parasitism. So the higher up you go on the x-axis, the more parasites there are. On the y-axis is basically the effects of climate change. One of the predictions of global climate change is that as our climate changes, it becomes more variable. And so what these results show here is that as climate variability increases this way, parasitism rates go down. So that's the results we're seeing from 500,000 caterpillars being raised in the lab. Basically, the parasites are very precisely timed to the cycles of nature, and if the caterpillars are hatching and living while the parasites are not timed to their cycle, the parasites miss them, and you end up with a lot more caterpillars, and that has tremendous impact for agriculture. So this is basically the results of all these teachers beating the bushes for 15 years or so. So that was my work in the summer of 2009. This summer, that's the view from my window at night. This past summer, I was on a program called Teachers at Sea. And this is run by the National Oceanic and Atmospheric Administration, which you may have heard of. It's called NOAA, the National Oceanic and Atmospheric Administration. It's a government agency. They have about a $5 to $6 billion budget, and their mission is to go out and study the oceans and the atmosphere. And they have lots and lots of research vessels where they're going out and doing marine research and atmospheric research 24 hours a day. And they invite teachers to go along on these expeditions. And I was actually selected to be, they selected 23 teachers this year to go out on their research expeditions. And that's me and their little news ticker on the front page of their website. They always try to promote their Teachers at Sea, and I was lucky enough to be the one they chose now to profile on their website. But that's me in the laboratory of the boat I was on. And if you click that, there's basically a link to an article. I was down in the Gulf of Mexico, and they decided that I aided in the Gulf oil spill research effort. And I came back and told my students I was there in July, which of course is when they basically stopped the oil spill. So I said, you know, once they got that done, I could come home. My work is done. But basically, what we were doing, we were out on this boat, the Oregon II. It's a 160-foot trawler, basically. There were 29 people on board, including me and a teacher from Ohio, and a team of scientists from different NOAA research labs around the country. And we went out in the Gulf of Mexico. You can see New Orleans there. There's New Orleans. We started in Galveston, Texas, and we went down towards Brownsville, Texas, which is right on the Mexican border, back up, and then to Pascagoula, Mississippi. And we worked 24 hours a day on this boat. We were trawling. We bring up our trawl net every half hour, and we would empty out the net, shovel it into baskets, and then process the catch in a research lab. Basically, we would analyze all of the organisms we caught, measure them, identify them, weigh them, cut their stomachs open to see what they were eating, and enter all that information into the computer. So it was a real eye-opener for me to see that NOAA is gathering information like this around the world on the 24 or so research vessels they have, 24 hours a day. And I was working with a team of very experienced scientists, so it was really interesting to see what was going on. So one of the purposes of the research was basically to evaluate the state of the marine ecosystem. They do this every year for going on 40 years now, and they do it to set fishing limits. They, based on what we catch, they decide how many shrimp the shrimpers in Texas and Louisiana can catch, or how many red snapper can be harvested sustainably. We also check fish to determine whether there's an impact from the oil spill. We would pack up samples and send them to a lab to be tested on shore. We also did chemical testing with various devices, testing the chemistry of the water. I got to run real expensive computer equipment. And we tested plankton. These are called bongo nets. We would sample them and then examine our catch under the microscope to see the state of the plankton in the Gulf and whether there was an impact on that from the oil spill. And this was the highlight of our trip. We caught a 450-pound stingray. Those are the deckhands on the boat. They're both about 6'2" and big, and that thing is dwarfing them. It was kind of interesting. You never know what you're going to catch coming up there. So That's what I did this summer. That's what I said, well, it's real interesting to go out and do this stuff and bring it into the classroom. And one of the other highlights I had last year was I got some of my students to apply for Earthwatch trips as well. They give out Earthwatch student fellowships. And one of my students was selected to also do a caterpillar study, although it was in California. So this stuff is rubbing off, and bringing it into the classroom does seem to have an effect. Thank you.
Thank you very much. I have no doubt that your students and their enthusiasm will rub off on your students. It will certainly rub off on you.
Too many board members have put.
Thank you very much. At this time, I'd like to open to the public. If anybody has any questions or comments, please state your name and town and limit your comments to 5 minutes.